distance for a tap conductor without requiring an additional overcurrent device at the distribution switchboard is not directly specified in the National Electrical Code. However, the National Electrical Code does provide guidance on the maximum length of a tap conductor in Section 215.3. Section 215.3 is titled Overcurrent Protection. Taps shall be protected against overcurrent in accordance with 215.3 or B. 215.3 addresses taps not over 10 feet long. Taps not over 10 feet, which is 3.5 meters, long shall be considered as protected by the overcurrent device protecting the circuit of which the tap is a part. Based on this section, it is generally accepted that a tap conductor not exceeding 10 feet in length does not require an additional overcurrent device at the distribution switchboard. This would allow the use of a through bus from the main switchboard to the distribution switchboard without installing an additional breaker on the distribution switchboard side, assuming the tap conductor does not exceed 10 feet in length. However, it is important to note that this is not explicitly stated in the National Electrical Code and may vary depending on the local authority having jurisdiction's interpretation of the code. It is always advisable to consult with the local authority having jurisdiction to confirm the specific requirements for the installation. To reiterate the key concept, the National Electrical Code Section 215.3 provides guidance on overcurrent protection for tap conductors. The general understanding derived from 215.3 is that if a tap conductor is 10 feet or less in length, it's considered protected by the overcurrent device of the circuit it taps from. This allows for a through-bus scenario without needing an extra breaker at the distribution switchboard, provided that the tap doesn't exceed the 10-foot limit. This interpretation isn't explicitly written as a rule for minimum distance, but it's an accepted practice. Remember to always verify the local requirements with the authority having jurisdiction because interpretations can vary. This section of the National Electrical Code focuses on protecting tap conductors from overcurrent situations. The 10-foot tap rule, as it's often called, is a practical application of this principle. If the tap conductor is short enough, the upstream overcurrent device will provide adequate protection. When designing or installing electrical systems involving tap conductors, consider the following points. Firstly, the length of the tap conductor is crucial. Ensure it does not exceed the 10-foot limit to avoid the need for an additional overcurrent device. Secondly, verify the specific requirements with the local authority having jurisdiction. Their interpretation of the code may differ. Thirdly, consider the application. The 10-foot tap rule is commonly applied in scenarios like a through-bus connection between switchboards. Fourthly, consult with a qualified electrical engineer or contractor to ensure compliance with all applicable codes and standards. Fifthly, document the installation thoroughly. This documentation can be helpful for future reference and inspections. The NEC is not always explicit about every possible scenario, so understanding the underlying principles is essential. In the case of tap conductors, the principle is to protect the conductor from overcurrent. If a short tap conductor is used, the upstream overcurrent device can provide this protection. However, if the tap conductor is longer, an additional overcurrent device may be required to provide adequate protection. The NEC provides specific rules for different tap conductor lengths and applications. It is important to understand these rules and apply them correctly. It is also important to consult with the local authority having jurisdiction to ensure compliance with all applicable codes and standards. The NEC Section 215.3 outlines the requirements for overcurrent protection of tap conductors. A tap conductor is a conductor that is connected to a feeder or branch circuit conductor at a point between the overcurrent protective device and the load. The purpose of overcurrent protection is to protect the conductor from overheating and damage due to excessive current flow. Section 215.3 specifically addresses taps not over 10 feet long. This section states that taps not over 10 feet long shall be considered as protected by the overcurrent device protecting the circuit of which the tap is a part. This means that if a tap conductor is 10 feet or less in length, it does not require a separate overcurrent protective device at the point where it connects to the feeder or branch circuit conductor. This rule is based on the assumption that a 10-foot-long tap conductor will not be subjected to excessive current flow that could cause it to overheat and damage the equipment. However, it is important to note that this rule is not absolute and there are some exceptions. For example, if the tap conductor is supplying a motor load, it may require a separate overcurrent protective device regardless of its length. This is because motor loads can draw high inrush currents when they start, which could damage the tap conductor if it is not properly protected. In addition, it is important to ensure that the tap conductor is properly sized for the load that it is supplying. The tap conductor must be able to carry the full load current without overheating. If the tap conductor is too small, it could overheat and cause a fire. The NEC provides specific guidelines for sizing tap conductors. These guidelines take into account the length of the tap conductor, the size of the feeder or branch circuit conductor, and the type of load that the tap conductor is supplying. It is important to follow these guidelines carefully to ensure that the tap conductor is properly sized and protected. It is also important to note that the NEC is not the only source of information on overcurrent protection. Local codes and regulations may also apply. It is important to consult with the local authority having jurisdiction to determine the specific requirements for the installation. In summary, NEC Section 215.3 provides guidance on overcurrent protection for tap conductors. The 10-foot tap rule allows for tap conductors of 10 feet or less in length to be protected by the overcurrent device protecting the circuit of which the tap is a part. However, it is important to follow the NEC guidelines for sizing tap conductors and to consult with the local authority having jurisdiction to determine the specific requirements for the installation. When dealing with electrical installations, it's critical to remember that the NEC provides a baseline for safety. While it aims to cover a wide range of scenarios, it can't possibly address every unique situation. Therefore, relying solely on the NEC without considering other factors can be risky. The authority having jurisdiction plays a crucial role in interpreting and enforcing the NEC. They are responsible for ensuring that electrical installations in their jurisdiction meet the minimum safety standards. The AHJ can provide guidance on specific requirements and interpretations of the NEC. They can also grant exceptions to the NEC in certain circumstances. Consulting with the AHJ early in the design process can help avoid costly mistakes and ensure that the installation complies with all applicable codes and regulations. The AHJ decision is final and must be followed. In addition to consulting with the AHJ, it's also important to consult with a qualified electrical engineer or contractor. Electrical engineers and contractors have the knowledge and experience to design and install electrical systems that are safe and compliant with all applicable codes and regulations. They can also identify potential problems and recommend solutions. It's best to hire a licensed and insured electrical contractor. This provides assurance that the contractor is qualified to perform the work and that they are responsible for any damages that may occur. When choosing an electrical contractor, it's important to get multiple bids and to check references. It's also important to ask the contractor about their experience with similar projects and their knowledge of the NEC. Finally, it's important to remember that electrical work is dangerous and should only be performed by qualified individuals. Attempting to perform electrical work without the proper training and experience can result in serious injury or death. Always hire a qualified electrical contractor to perform any electrical work. In summary, when dealing with electrical installations, it's important to consult with the AHJ, a qualified electrical engineer or contractor, and to hire a licensed and insured electrical contractor. This will help ensure that the installation is safe, compliant with all applicable codes and regulations, and performed by qualified individuals. The NEC guidelines are developed and updated regularly by the National Fire Protection Association, a non-profit organization. The NEC is revised every 3 years to reflect changes in technology and industry best practices. The NEC is widely adopted by states and municipalities throughout the United States. However, some states and municipalities may have their own electrical codes that are more stringent than the NEC. It's important to check with the local authority having jurisdiction to determine the specific requirements for the installation. The NEC is a complex document that can be difficult to understand. There are many resources available to help understand the NEC, including training courses, seminars, and publications. The National Fire Protection Association also offers a variety of resources, including the NEC Handbook, which provides detailed explanations of the NEC requirements. The NEC is an essential tool for ensuring the safety of electrical installations. By understanding the NEC requirements and following the guidelines, it's possible to design and install electrical systems that are safe and compliant with all applicable codes and regulations. Always prioritize safety when working with electricity. The 10-foot tap rule, as discussed earlier, is a specific application of the broader principles of overcurrent protection within the National Electrical Code. Understanding its limitations and proper application is crucial for electrical safety. Let's delve deeper into some of the key considerations when applying the 10-foot tap rule. Firstly, conductor ampacity. The tap conductor must have an ampacity sufficient for the load it serves. While the 10-foot rule allows the upstream overcurrent device to provide protection, the tap conductor itself must be sized to handle the load current without overheating. Consult the NEC ampacity tables to determine the appropriate conductor size based on the load and conductor type. Secondly, overcurrent protection device rating. The overcurrent device protecting the main feeder must be rated to protect the tap conductor. This means the overcurrent device rating should not exceed the ampacity of the tap conductor. If the overcurrent device is too large, it could allow excessive current to flow through the tap conductor, potentially causing it to overheat and fail. Thirdly, tap location. The tap must be made in a manner that ensures a reliable electrical connection. Poorly made taps can create hotspots and increase the risk of fire. Use approved connectors and follow industry best practices for making electrical connections. Fourthly, enclosure requirements. All electrical connections and overcurrent devices must be properly enclosed to protect them from physical damage and environmental factors. The enclosure must also be appropriate for the environment in which it is installed. For example, enclosures installed in wet locations must be watertight. Fifthly, documentation. Keep thorough records of all electrical installations, including tap locations, conductor sizes, and overcurrent device ratings. This documentation can be helpful for future maintenance and troubleshooting. Sixthly, potential hazards. Be aware of potential hazards when working with electricity, such as shock and arc flash. Always wear appropriate personal protective equipment and follow safe work practices. The 10-foot tap rule is a useful tool for simplifying electrical installations, but it's important to apply it correctly and understand its limitations. Always prioritize safety and consult with a qualified electrical professional if you have any questions or concerns. The through-bus configuration, which this situation refers to, is a common method of distributing power within a facility. In this configuration, a main feeder runs through a series of distribution panels or switchboards, with taps taken off the main feeder to supply power to individual loads or branch circuits. The advantage of a through-bus configuration is that it can reduce the number of separate feeders required, simplifying the electrical system and reducing costs. However, it's important to design and install a through-bus configuration correctly to ensure safety and reliability. Here are some key considerations for through-bus configurations. Firstly, feeder sizing. The main feeder must be sized to handle the total load of all the taps connected to it. This requires careful load calculations to ensure that the feeder has sufficient ampacity. Secondly, overcurrent protection. Each tap must be protected by an overcurrent device to protect the tap conductor and the load it serves. The overcurrent device rating must be appropriate for the tap conductor size and the load current. Thirdly, voltage drop. The voltage drop along the main feeder must be kept within acceptable limits to ensure that all loads receive adequate voltage. Voltage drop can be minimized by using larger conductors and keeping the feeder length as short as possible. Fourthly, coordination. The overcurrent devices in the through-bus configuration must be properly coordinated to ensure that a fault on one tap does not trip the main feeder overcurrent device. Coordination studies can be used to determine the appropriate overcurrent device settings. Fifthly, maintenance. Through-bus configurations require regular maintenance to ensure that all connections are tight and that the overcurrent devices are functioning properly. Infrared scanning can be used to detect hotspots and identify potential problems. The through-bus configuration is a powerful tool for distributing power, but it requires careful design and installation to ensure safety and reliability. Always consult with a qualified electrical professional when designing or installing a through-bus configuration. Remember that the NEC serves as a foundational guide, but practical application often requires interpretation and adaptation to specific circumstances. Always prioritize safety and consult with qualified professionals when working with electrical systems. The NEC should always be consulted in its most recent edition for the most up-to-date information.